Okay, how to graph a quadratic. And what's very important is our a. So if we were to write the kind of parent function of this, it says y is equal to a 8k, or x minus h squared plus k, and I'll write all those letters in here. Okay, the h, so this negative h and this positive k here, are really only important for the vertex. Okay, I want you to think of it like the vertex of whatever this is. The x value is our, specifically just our h, so kind of the opposite of what number's in there. Okay, and the k value is exactly what the k is. Okay, see how there was a negative in this one? So if this was negative 5, it would be 5. Okay, that would be the vertex's value. So
X
and the y of the vertex. Okay, but in order to graph the rest of the parabola, the a is extremely important. So let's say I decide to write this function. Okay, so it says y equals x squared. In this case, h and k are both 0. Okay, so that means my vertex is at 0. That also means the a value is technically 1.
Yeah, if there's nothing there, you add a 1.
Yeah,
right?
so there's two ways you can think of it. There's one is called a step pattern. The other one you can do like squaring. So we start at the vertex, and if I go over 1, this is going to be squaring.
Yeah.
If I go over 1, what is 1 squared? Do you know?
You
can always use a calculator.
1 squared?
I'm going to tell you what it is, okay? But grab a calculator in the meantime because I ask you a couple more. It's just 1.
Okay.
So we'd go over 1,
It's just...
and because it's just 1, we go up 1. Okay? That same idea works for negative 1. Negative 1, so if I go to the left,
Make this square, yeah.
and I square it, negative 1 squared, put it in your calculator there.
Negative squared, how do you square it on this calculator?
That button right there.
Oh, right here?
Yeah. Is 1. So we go to the left 1, we go up 1. Okay?
Up 1.
So this is kind of the rule, and as we go through, I'll show you a step pattern that will help. So from there, I go back to the vertex. And this time I always start at the vertex again. I go over 2. Well, what would 2 squared be? Why don't you try it in your calculator?
2 squared?
4. Yeah? So that means we go up 1, 2, 3, 4. That's the next dot, okay? Let's do the same thing. What about negative 2?
2 negative squared? 4.
Yeah, that's right. So we go over 2, up 4 again. And then the last one, go right back to the vertex. Okay? Let's go over 3. 1, 2, 3. What's 3 squared going to be?
9.
9. And negative 3 squared will be?
9.
9. Okay? So what's happened here is there's a step pattern.
Oh.
Okay? And I'll show you what the step pattern actually is. Here's our parabola. The way the step pattern works is it actually goes like this. We go over 1, up 1. Over 1 again, up 3. Over 1, up 5. So we go
this counts for
1.
Every...
Yeah, for whenever the a value is 1. And I'll tell you how that changes after. So we go over 1, okay, up 1, over 1, up 3, over 1, up 5. How many do you think we'd go over 1? How many would we go up the next one?
3, 5, 8.
So this pattern, we go 1, 3, 5, we would go up 7. It constantly increases by 2.
Oh.
Okay? Now, here's the thing. What if this happens? And it says y is equal to, and in this case, I'm going to put the value of 3 here. 3 x squared. Well, that kind of changes things. Okay? This step pattern, it works really good. But what we do now, and these numbers we have to remember. 1, 3, 5, 7. What would the next one be?
7, 8, 9.
9, and then
11.
11. Okay, so we keep that in mind. It doesn't fall on this one.
Yeah.
We multiply these steps by the number, whatever the a value is. So because it was 1, when we multiply by 1, does that change anything?
No.
No. So they all stay the same. So we didn't really talk about it.
Yeah.
But now that it's 3, that's going to change things. Okay? So we would now take our step pattern, and we have to multiply it by 3. So what's 3 times 1?
Sorry, 3.
Yeah. So that means we go, and I'll do this one in red, over 1, up 1, 2, 3. Over 1, up 1, 2, 3. Okay? The next step says 3.
Yeah.
What's 3 times 3?
9.
9. So we'd go over 1, up 9, which would be here. So if you notice from this red one, it's much thinner or stretched compared to the black one.
Yeah.
Okay, and that's because the A value is greater than 1. Remember we kind of talked about that before when A is greater than 1. Here's another idea. What if this happens, and we'll do it in a different color. Y equals, I don't know, maybe 0.5. And I guess I'll do a different color to help us out here. What's this blue? That's not a good color. We'll go this blue. What if it's 0.25, or as a fraction, that's 1 over 4, okay? X squared. Well, we take the same step pattern, okay? And I'm going to bring out another graph just so it's a little cleaner to look at. Another graph. This time, because remember our step pattern, the vertex is still at 0, okay? But because of our step pattern, we go up 1, then we go up 3, then we go up 5, then we go up 7. But in this case,
because that's only for when it's going up, the A is 1, right?
Yeah.
Okay.
We have to multiply by 0.25 each time.
Oh.
So get your calculator out, and we're going to multiply by
so
those.
So this is these these 4 numbers are something I should memorize for every like going up, but then anytime A is a different number, you times these by...
Exactly.
Oh, so maybe I should write down...
I'll print it for you.
Okay.
So let's do 1 times 0.25. What's that going to give us?
1 times 0.25. Oops.
Yeah, that's right.
0.25.
So what that says is we go over 1 and only up 0.25. So we'll estimate. It's about there. We go over 1, up 0.25. Okay. And then from there, what's 3 times 0.25?
0.75.
So I got to go up 0.75. So I'll go over 1 from here. And actually, it'll take me right to here. Okay? 0.75. So we go up that much. What's 5 times 0.25?
5 times 0.25. 1.25.
1.25, okay. So that means we go over again 1, and we go up 1.25, which is about there. Over 1, up 1.25. And then the last one, what's 7 times 0.25?
7 times 0.25. 1.75.
1.75. Okay, so I'll help you. We go over 1. 0.75 is here, and then another 1. So it goes up to about there. Okay, so this parabola is much wider looking than the other ones, and that's because our A value is less than. So A is between 1 but greater than 0. Do you recall that rule when we're doing it? This one's much wider than the ones above.
So that's compressed?
Yep, this is compressed. So depending on what the A value is, that's going to change our step pattern. Right? We always got to remember our step pattern, and we just multiply the step pattern by the A value, whatever the A value is in that.